yesterday we talked about introduction, word count example. We also talked about pigletin versus SQL, pigletin versus MapReduce. Then there were few use cases we discussed. Then the general philosophy, pig eats everything, pig fly, and pig lives anywhere, and pig is domestic animal. And then we talked a bit about installation and using from Cloud Labs. Then local mode we briefly went into. Command line argument, yes. Then the prompt, a little bit about prompt. Then average value example. Okay. So we talked about an average value example. Then data types, then schema, then basic construction, then load, diagnostic as in explain and describe, store and dump, for each we talked about, and then we talked about filter, order by, join, limit and sample, right? And we were on parallel. Okay, so any questions till here? All these, there are around 24 topics which I've just gone through. Do you have any questions based on that? Can pig be used in non-MR cases? So yes, very good point. So pig guys are actually working so that pig becomes the default language when it comes to parallel processing. Okay, and also in general processing. So pig guys are actually working towards that kind of a goal because given the simplicity of pig Latin, it is actually apt for even RDBMS or even for databases like MongoDB. I actually prefer Pig Latin over MongoDB's aggregations. And MongoDB provides you aggregations to query the database, but Pig has got its own strengths, right? So they are working on it. That's why they say that Pig lives anywhere. So their basic philosophy is that they are trying to make Pig live everywhere. Okay. But so far, I have not seen any other versions of Pig that fits elsewhere. The only thing which I've seen is using. There is a video which I have posted earlier where I've integrated MongoDB and Hadoop, where anything I did at MongoDB went to the sorry, when anything while using Piglet in itself, I was able to use while using Hive as well as Piglet in, I was able to use MongoDB. All right, this is a very good question. And yeah, any other questions before we move on? All right. Okay. So moving on. So I'm assuming that all of you have been very busy and you have not been query. But make sure this whole week you should finish all these 8 questions. These 8 questions are very, very simple questions. And it should not take more than half an hour to actually finish all 8 questions. Okay. It's just a matter of focus. All right. So we are done with, right. So when we say that the basic philosophy of pig is one of the pillars of basic philosophy of pig Latin or pig is that pigs fly, which means pig is extremely focused on optimization. So first step into the optimization. Till now we did not see much of an optimization steps. First step from the pig side is the keyword called parallel, right? If you guys remember that while creating MapReduce, there was something called partitioner. And in partitioner, we used to mark that how many reducer do we want? Or even without partitioner, we were able to tell that these many reducers we want. All right. So parallel is the keyword that facilitates this. Okay. So as expected, because parallel basically impacts number of reducers, it wouldn't impact the number of mappers. Number of mappers is actually impacted by how many how many pieces, how many blocks are there for a file, right? So and almost everywhere you can write parallel. So when we say load nysc underscore daily as this, after loading, while doing a group by, you can append parallel and then number of reducers you want. Okay. So if you want your group by to be done on 10 parallel machines, or the reduction phase should be executed on 10 parallel machines, then you say parallel 10. Okay. Now let's take a step back and go to the first step. Load nysc daily as this, and if we put parallel over there, it wouldn't make any difference. While parallel 10 will make speed up the group by functionality uh, a little bit more. I'll not say that it will speed up by 10 times. It will definitely speed up by some amount. Okay. Because here there are high chances that if the data is smaller, then there are chances that shuffling might network transfer might take more time than the actual sorting, right? And moreover, sorting is any bit done by the mapper nodes. Most of the sorting, only the merging is done by the in the reduce phase. Now, it will improve the process only if there are so much work to be done in the group by phase, or any other complex processing need to be done. Okay. So parallel is a keyword which can be also set by default. Okay. We can say set default parallel equals to 10, right? So here, or any reduce phase which, as we had been discussing, every piglatin gets converted into map reduce phases. So every map reduce phase, the reduce part will get 10 parallel. If you set the default number of reducers or default underscore parallel equals to 10 or 20, so by default any reducer will get 20. So you do not have to think about which where should I apply parallel. Okay. So similarly, parallel wouldn't impact filter command. Therefore I went through those immediately questions, that which one has reducer, which one doesn't. Okay. So filter wouldn't have, load wouldn't have any impact of parallel keyword, but they all support parallel keyword. Okay. Now, if there is no parallel keyword available, pig itself tries to make the things parallel if your input size on a reducer goes beyond 1 gigabyte. right? If you are sorting or if you are doing a group by on below 1 GB data, it's okay. It won't create any more it won't create more than one reducer. Even if you have not specified parallel keyword, then also it will au- automatically create more than one reducer if the size of the input goes beyond 1 gigabyte. Okay, that's the default settings. Okay, what happens if any reducer fails in those 10? If any of the reducer fails, then it will try to allocate it to another machine, and in case the problem is severe, it will just give up. Okay, so even if you have not specified parallel, by default, the moment your input size grows beyond 1 gigabyte, it automatically creates more than one reducer. Okay, and similarly, if you have 10 gigabytes, it will anyway create 10 reducers. All right. Now, okay. I- So I'll ask in another way. Or will parallel keyword have any impact on this? Quick question. Anyone? All right. Good. Good. Yes. So parallel keyword will not have any impact on this. Okay. Now, okay. Oh, I've actually unnecessarily created this. Okay. That's anyway there in the previous one. That's anyway there. All right. So, yep. So you have already answered the question and good. Now, all right. So the importance of parallel is clear to all, right? Why do we need parallel? Cool. And so the next keyword is flatten. So we all talked about group by. In group by, basically, if you have this data, if you have this data, okay, and say you have x.txt, which looks like this data, and you say x equals load x.txt, and using pig catalog, sorry, pig loader, not pig catalog, that is Hive, pig catalog, and we say this, and when we have to, and then we say y equals group by group x by dollar zero, right? Now, if we dump y, what would it be? What would it be? It would look like we are saying group by Sandeep, and we'll have another bag of values called C, C, and C++. Okay, so this is how it would look like. And similarly for Arun, it is going to be shell and C. Alright. So this is what group by says. Group by basically creates a bag out of the values. Okay. Group by essentially creates, it won't be like this, it will be something of this sort. It will be something of this sort. Okay. Alright. So when we do group by, this is what happens. Similarly, there will be Chintamani with Java and C++. Okay. So all the rows which become the basically the part of that bag, and this is what happens, right? So now when we do flatten is exactly opposite of group by. Given this input, we'll get this output. Okay, Siva has. So Naveen, you wanted me to repeat something? The parallel part? Oh, which one essentially? I missed your question. My question was that when we are given this data, if we do group by, oh, the question was basically this one, same question, okay, regarding parallel. So never mind that. Okay, never mind that. Moving on. Now, group by results in this kind of output, right? Now, flatten is exactly opposite of that. When we say flatten, all we get is that this becomes one thing per row. Okay, that becomes one thing per row. Okay, so Siva's question is how pig decides the size which is coming to reducer before running the reducer code or during. So it is basically tries to do a sort of a quick sampling. Okay, and the size computations are very rough. Size computations are very rough, and they are generally based on the size which is given out by mapper. And that's where even before reducer is executed, number of reducers are decided based on that. I'm trying to answer Siva's question. Okay. And moreover, Hadoop continues to gather the statistics on your data, and it basically tries to infer a lot of information because of your past runs. Okay. Now, so flatten essentially is opposite of your group by. Okay, so this will result in one row, one language per row, and this is what you will get. Okay, so all you have to do is load your file, say for each x, and generate name and flatten languages. Okay, flatten languages, what it will do is it will basically take this bag, and out of it will generate one I mean it will generate one row per data. Okay, this just opposite of what is a group by. All right. So if we can quickly see if it works or not. So, okay, so we say pig. All right. So we'll have to create a new file. So let me just create. Okay, so we have flatten, and now let's say f equals load flatten, and we say, and when we say dump, what should we get? Okay, so Vishal's question is there any specific format the file should be in? Do you mean for the script to handle the load part you're talking about? Yeah, so basically your data has to be in the format of tab separated. If it is comma separated, then you will have to use a keyword called using pig loader. See, it has automatically loaded this. And if we say flatten output equals flatten for each f generate $0 and flatten $1 and dump. It's doing something. All right, so let me just see what happens after this. As name and length. Why it's wrong? Okay. Okay, I need to probably define that I'm trying to load. Okay. Yeah, you're right. I forgot to put the curly braces. So my file name is flatten, and let me just see if I have. Oh, okay. So I need to basically give the proper folder name, ls data, and the data contains my file. So instead of that, we can just say cd data because it remembers the location. And okay, so yeah, so what is the t command in tuple? Yeah, so we basically are saying that t is a tuple. Okay, we are defining that our language is a bag of tuples. So whenever we define a bag, the t is always this is the syntax to tell that this is what it is. Okay, so let me just act a copy paste guy. Yeah, now you can see the only difference between my approach and this approach is that it has specifically said that languages is a bag. Okay, therefore it has figured out the proper format. Earlier, in my case, it was considering it to be, let's just see, fo is not no longer there. In my case, the it was basically considering it to be a byte array, and that is why it did not flatten it. Okay, now you can see it is flattened out. All right. So this is how the flatten works. Practice a bit and you will get the hang of it. Okay. Now, an important part. So whenever whenever you are writing your pig script, there will be lots of circumstances when you would like to call your Java function. There, although I had mentioned that there are so many functions, and I have also mentioned the various links at various places that there you can go and look up all the library of the functions. But still, there would be circumstances where you would require Java functions in place. For example, the generation of UUID. UUID generation is something which is unique to Java, and we want that to be in place. So, in all these circumstances, it is actually possible to call any of the existing Java function, whatever it is. Okay. So, how do we do that? The syntax is first, say for example, we had to convert something into hex string. All right. So all we needed to do is we needed to define, uh, we had to first define a hex function, And this hex function is basically a static function in Java. And all you need to say is invoke for string, and this is the function which we are looking for, and this is the argument we will be passing to it. This is the argument which will be returning, and invoke for string basically would give string as the input to this function. Okay, so the function in a package called java.lang, the class name is integer, and the function name is toHex string, and it will return an integer. Okay, it will return an integer. No, actually it will return a basically a hex string. Okay, it will return a hex string. I just need to understand this part. So given an integer x, y, z, whatever, 1, 2, 3, whatever, it will return you the hex string. Okay. So here, so we defined a function hex which takes int and gives you a string. And this is usual. This is the way we loaded our data. And after you have loaded your data, you are essentially passing your record, each of the record, through a function called hex, which we just defined over here. All right. Whatever function we have defined over here, we are just using that one. Okay. And so I've just executed in parallel. Let's see what happens. All right. So basically given an integer. So there is a function in the integer class in Java called toHex string, and that's what we are trying to do that. Okay. Okay. So Apu's question is flatten. Flatten basically is opposite of group by. Group by groups the elements based on a key, and flatten converts multiple values to multiple rows. Here there are multiple values C, C++, and it has converted into multiple rows or multiple tuples, we call them here. Okay, it's just opposite of what group by does to you. So a tuple is something which is in the bracket here, right? Curly brackets tell that this is the thing which I've just selected is the bag. I'm answering Veerana's question. So it's a bag from here to here, and this bag contains tuple. These are each rows basically, if you think about that perspective. So it's a table. Basically, this is itself is a bag containing these are the tuples, and each tuple have first value and second value. And what is second value? Second value is another bag containing first tuple, second tuple. All right? This is how we look at it. If we could have something like this also, right? We could have something like this also, right? Therefore, it's a bag. All right? Now, here you can look at it. We just converted our number, the integer, into a hexadecimal number. Sounds cool? So the volume, if we have not seen what does divs look like, so let's say divs 10 equals limit divs, and say we 10, and we say dump. All right. Now the volume, the last one basically is a decimal, I think, and that has been converted into hexadecimal using a Java program. Sounds cool to you? So we were able to happily execute a static function. On the similar line, you can execute you can execute a function from your own library. Okay, but the only difference is you will have to define register acme.jar. Acme.jar has to be there in that same folder structure. Wherever you're executing the pig from, acme.jar should be there. Acme.jar does not necessarily need to be in HDFS, it needs to be in the local file system. So yeah, volume is being passed to the hex function. Yep. And this hex function is something which is actually we are trying to call the Java function. Okay. What happened to this guy? No, in the directory from which you are running pig. I was answering to Naveen's question that where the file, this jar need to be located. Okay. Now you can see that it's a decimal number. The volume is a decimal number. First we converted it into integer and then passed it to hex function, and then acme dot and then hex function is invoked. Okay. Now those who are not familiar with acme dot jar in Java, dot jar is equivalent of dot dll or dot. It's basically a whole jar of I mean that contains multiple classes. All of your code is there whenever you're coding in Java. Jar is basically bundle of all of your compiled code. Okay. Now here in this example, acme.jar is just an example where I'm saying that you have got a legacy complicated code that you would not like to write again. And even if you're writing, you'll have to anyway write in a custom language like Java or Python. So why can't we just use that one? Use an existing legacy code inside our pig. So here in this case, we have some currency converter which is legacy. I mean, in acme.jar is something converting dollar to euro using our own logic where we try to you know extract as much money as we can out of it. So, I mean, we have got our own custom logic. Your company has got your custom logic. Now, you want that particular logic to be executed, not some other one. In those cases, you would register your own jar and then you define a function, first of all, called convert, which is nothing but a function which is defined in your jar like this. And then it takes i- which we are giving these two arguments to it. Okay. All right. So you can think of it this way that okay. Now the same function convert you can use just like we used here. Okay. Just like we used here. Just a little bit of differences in the syntax. All right. Now similarly on the same line you can use Python function also. If you have got a Python function or Python file called production.py, and you can register that production.py using Jython, and you can give it a name called bball. Okay. Now any function which you have defined inside this production.py, you can happily execute it. You can happily execute it in that manner. Okay, because this Python file might have hundreds of functions, and we can call each one of those, right? So so why do we, these are generally called streaming, or I mean we are streaming through the data using these functions, okay? Or these are also called user defined functions, but user defined functionalities go beyond, far beyond this. You can, pig allows you to define your own loaders, like pig loader you saw. Similarly, you can define your own loaders, but that is beyond the scope of our discussion here. All right. So some of the custom code, this actually is cool when you are in middle of thing and you realize that, hey, this can be done very easily using Python or Java, and you can just start calling your functions. Okay. All right. And basically this, so fine, whenever you have to call external function, you use this syntax, right? Now now the next question here is something called for each nested. Okay. The next point in the discussion today is called for each nested. And in this, basically, we have got key and value. And say, imagine that we are basically counting the names of various city. And for each city, we are given names. And the objective is to find the distinct name in each city. How would you do it using existing, whatever you have learned so far? So as you can see, total number of distinct names in Bangalore are Sandeep and Vivek, which are two in counts. Similarly, in New York, NYC, you can see there is only John. So the total count distinct names in each city is, for Bangalore it's two and New York it's one. So if you have to do this, what will you do using Pig script? Whatever we have learned so far. Yes. Good, good. So we'll have to do, no, actually it will be other way, Siva. It will be first group by then distinct. Right, right. Distinct and then count. Okay. So for this kind of need, it's quite often that you will face this kind of need. So Pig went ahead and created a syntax for this kind of situation, because every time you will be again and again, so to avoid multiple lines of for each, okay, to avoid multiple lines of for each, they basically came up with nested for each. Okay, that made life really simpler. Otherwise, what you will be doing is, you will write first for each, then second for each, right? First, what will you do is do distinct first. Okay, once that is done, then the next set would be again run for each and then do the count. Okay, and to make that life easier, they they did something called for each nested. So for each group, and then you can put curly braces here. Okay. And inside curly braces, you can write just like another statement above. You can write those statement here. Okay. Just like above these statements, you can write similar statement inside the curly brackets. And that is why it's called nested. It's a statement inside a statement. Okay. So this is called for each nested, where we, yeah, dot is basically an operator where we have dataset dot column name. Okay. Dataset dot the name. Okay. For each tuple, we can reference to to basically the field using the dot operator. But the first statement in for each is not necessary. You mean to say this one? No, it's necessary actually. We need to do a distinct over here. We need to count the distincts out of all the names. Yes, yes. We can do people dot dollar zero. Yes, that's right. No, group by doesn't do it. Group by does it only for the city names, not the name of the people. Group by wouldn't do the distinct on the names of the people. You'll have to do it. Group by will only take care of the keys. Sounds sensible? You are saying group by on the city and then distinct on the value and then count. That's what we are trying to say here. So instead of running multiple for each again and again, we are saying run for each once and do these operations. So effectively reducing number of trips to the disk for reading the data. That's what it does. If you are running two different maps, it would be really complex because if you have two for each, there will be two mappers. And if you have two mappers, you are reading the file and data twice. Therefore, they merge the two for each together so that you can do multiple operations on the same data. So this is a added advantage of having for each nested, other than making your life simple. All right. Any questions still here? Okay. Is this the only advantage, Shrikant? Let me. Okay. Right. It is same as the for loop. You're right, Apur. Okay. Right. All right. Let me also see if I can do something about it. So these numbers, line numbers, are not part of the code. They have just put the line numbers for making it easier. Okay, okay, let me try to answer multiple questions. Yeah, so the biggest advantage of having a for each nested is to basically do the optimization. You could do the same thing using a single for each. Okay, you could do the same thing using single for each, but But I mean, you could easily do all of this using multiple for each, but each for each results in multiple mappers, and therefore, when you have multiple mappers, you will end up you will end up having multiple trips to HDFS. All right. Therefore, it makes sense to have combine those two for each into a single for each called for each nested. So that is the basic advantage of doing it. Okay. 3.2 is not clear. Okay. So this is a little different in the nested part because generate is not generally a valid statement elsewhere, right? So that is the only part unclear. So earlier we were saying for each xyz and then generate, right? Here we are saying for each uh, your data set, then statement 1, statement 2, statement 3, and then generate. The last line is our generate. Okay. And most likely you can actually put multiple generates. Yes, group is a keyword, not a keyword. Group is basically the default name given to the given to the field on which the data was grouped. Okay? Okay. Now let me answer Naveen's question. I keep getting this error after group by when I try to do count. Yeah. So generally when you do group by, right? So group by does not have the count kind of a functionality over there. You always write functions called count inside for each, right? Unlike your RDBMS where you can combine these functions with group by, here group by simply groups it, right? Group by's role is only to define the key and that's all. Okay. And therefore group by the count doesn't make sense there. Count is only you can do that in the for each. So all right. Good. So everybody clear on for each nested? Now awesome. So now let's talk about a scenario. Let's talk about a scenario where you are given one huge file containing people's name and their country. Okay, country, right? Now you have to convert, and also you are given another small file containing country and their ISD codes. Okay, and what do we require over as an output? Okay, what do we require as an output is instead of country we require the ISD code. Okay, and remember what is the essence of this question is the second file is relatively very small. Okay, second file is relatively very small, say 100 kilobytes at most, or maybe you can say 10 KB. Now, if you do the usual kind of mapping, where if you do the usual kind of mapping, where when we are joining the two data sets, dataset 1, dataset 2. Okay. So if we are joining the two data sets, we are going to again do all sorts of mapping, right? If these two files are located here and there, there's too much of work. Now, that can be very well optimized if we just load this file, second file, which is very small, second file into the memory. Okay, just we load this second file into the memory and we have a single mapper which gives out these 1 billion entries, right? So you will not even require a reducer phase. Okay, a single mapper will finish everything. Does it make sense to you? No? So let's say that we had a very small data, we have kept it in the memory second file. And all we need to do is write a mapper which reads row by row, which gets row by row or line by line and prints out the country code instead of country name, right? Pretty simple, right? Instead of there could be other approach that we form here there is a mapper, there is here a mapper, and this one is giving out in as a key and this as a value, and then we do the standard join we were trying to do, right? That will become really complex. If you can and but if we just put the second file into the memory, it actually solve our life a lot, right? So another example of how pig is trying to optimize, so for each nested was one second attempt on helping you optimize your data your flow after parallel. The third one is the fragmented join, we call them fragmented joins. Okay, because second file is very small, so it is okay to load it in the memory and then do the processing rather than doing a standard map reduce. No. So so say you have this file is located on 10 data nodes. Okay, this file is located on 10 data nodes. What you do is on all the data nodes wherever you are sending the mapper, you send this file and load it in the memory before running the mapper, right? So in such circumstances, you basically optimized a lot, right? And therefore pig also provides you a syntax to do it. Okay, as a thumb rule, when you are trying to join two data files, when you're trying to join two data sets, one data set is very smaller, such smaller that it is okay to load it in the memory. In those circumstances, you use fragmented join, and the way we do is using a keyword called replicated. Okay, so okay, yes. So in all nodes, we will have second file in memory, and that's how it will optimize it, right? So whenever you are joining here, if you see what we are trying to do is we loaded persons, we loaded country code. Okay, we have got two data sort persons and country code. We are trying to join persons and country code on country, right? On the country name. Now, when we are trying to join these two data sets, we if we mark using replicated the against the against the name. uh, I mean, when we say CC by this, which means we are saying country code dataset is small, so you can copy it in the memory and it'll be really, really fast instead of trying to join it, right? So it's actually pretty straightforward to take this call. It's really straightforward. So whenever you have two dataset, one two huge, one very small, then you use replicated. Okay. So you can take this call quickly without this. You can even think without even thinking in terms of map reduce. You can take this call whenever you're joining two data sets, one of which is very, very small, so small that it is okay to load it in the memory on all the data nodes, replicate it on all the data nodes. If it's okay, then use the keyword called using replicated against the data set. So CC by country, we are saying join persons by. So had there been no replicated clause, this will look like this. Now we realize that hey, this CC is small. Had this persons table been small, we will say this using replicated over here. All right. Now we realize that oh, CC is quite small, so we can just say using replicated, and we are happy. And you will suddenly see uh, a major jump in the performance. Major jump as in maybe 10 times jump. Okay. So Vishal, should I again answer your question? So basically say this is what it is, all right? And we realize that hey, person's table is quite small. All you need to do is before comma, you just say using replicated, okay? And pig is happy. Pig will make the person's table load in all memory. But since person's table is huge, you don't use there. Here in our example, CC is using replicated, okay? If we give persons as replicated, pig detects that it should not be. I don't know that part. I haven't tried that. Sivas pointed that if we make a mistake and we realize that we made a mistake by putting using replicated against the person's table, that does pig detects it or will give memory overflow? In my opinion, it should give a memory overflow because it will try to load it in memory, and that's where the problems will occur. Okay. Is anybody else unmuted? All right, cool. So everybody is happy with the fragmented joins. Fragmented joins occur replicated. Okay, don't forget that part. So ideally, we should be just forget calling it fragmented join. We should just call it replicated. Okay. Now the next step is skewed data. Now, what does it mean by skewed data? So there are circumstances when you are doing group by or when you are trying to join the tables. Okay, when we are trying to join two tables. Okay, we are joining table A and table B. For one key in table A, there's so many values in the table B. All right, and similarly, Similarly, for for some keys, there are very small number of values in another one. So when you are joining the two tables, what actually happens is you take the one key from one table and try to find out that key in another table and find out all the values for that, and then you join them together. Okay. Okay. And in some circumstances, your values are heavily skewed as in that when you are joining, and joining essentially means performing the reduce phase. So in the reduce phase, if the data is so huge, then there could be, a disaster in waiting. In such cases, what you should do is you should mark the table as skewed. Okay. So imagine there is a table called users. In these users, the for some cities there are billion users, and for some cities there are 3 users, 2 users, 4 users, right? So in such circumstances, you should mark this table while joining on this keyword called city as skewed. Otherwise, what will happen is that it will try to do it will when it samples the data, when pig starts doing group by or does a syllable sampling, it, it will think that in case in sample some keys came as only 3 or 2, and instead of keeping it in the disk, it started keeping in the memory, and that's where the problem would start. So in those cases where when you know that the data is heavily skewed, when I say heavily skewed, the value for a key is x, and the value for another key is a million times x. Okay. So that's when we call it skewed, a factor of a million times. All right. So in those circumstances, right. So Srikant, this is a very good question. You should send it to all. How do we determine the skewedness in range of 1 GB data? Do we need to do any primary preliminary examination? So in general cases, you do not use the keyword called skewed. Only when you realize after a point of time, when you have done it basic work and when it's running, and then you see, okay, this thing is trying to load it in memory, and therefore there is a problem over here. Okay. So how should I say it's that okay, so how do we do the analysis is a very interesting phenomena. So analysis, again, this prediction of the number of keys, you will basically write another big script to figure out if your table is skewed. Okay. To assist pig upfront to make its decisions wisely, because pig itself tries to sample a lot of data before taking a call. Okay. So generally the number of values of one key against number of values in another key, if there is a if there is a 1 million times difference, then we call it a hugely skewed data. Okay. We call it skewed data. Srikant, was I able to answer your question? And to figure out skewedness itself, you will use again another big script to determine how, just count the keys for all the rows. I mean, it's just a standard script. So, say for example, in the table called users, all you need to do is, uh, you know, group by keys, and in the values you can write it as, count for each, and then count number of keys for each. Okay. And then in the values, you can basically do a sort by values and see the minimum and the maximum. Okay. So, all right. So this is what we have. Now, skewed is actually quite useful in cases when I mean it helps pig in making a educated guess rather than just sampled guess. And the reason is i- pig believes that you know your data better than pig. Okay. In those circumstances, you should inform pig that this is skewed, or this is should be replicated, or you can use parallel, because you know that when you're doing parallel, you know that your reduce phase is heavy. The things when you're reducing group by, and then we say summation, this, that, if you do all of that, it is going to be, I mean, you know that your logic is heavy. And that's when you can inform pig that, hey, I want to have these many parallel. So similarly, these are the one. Now, there is very interesting thing which pig has done further, which I mean we realize it later only. Now, at various point of time, we know that our data is already sorted. Okay, we know that our data is already sorted. So we have just run our join in the previous session. We say we have A, B, and C, right? So we joined A and B, and we had joined B and C on the same key. Now the results of both these data will be already sorted, or we had stored this result in the file earlier, okay, where the data is already sorted by the key which on which we want to join, right? If we already have data sorted by the key on which we are trying to join, then there is no need of sorting it again, right? There is no need of sorting it again. And therefore, if you know that part, then you just say merge rather than using merge, which means that pig doesn't need to sort either, neither of these tables, neither daily nor divs. Okay. All right. So, how many of you actually have used a command called sort in Unix? So, sort command in Unix, how many of you have used? I'll repeat. I know that I've not explained it clearly. Okay. Vishal have used, Avdesh have used. Who else? Sort command in Unix. Good, good. So now my next question is, if you have two files, and you are sorting the combined output. Okay. If you have two files and you are sorting the combined output, and your approach is merge two files together and sort the result, right? So first step is merge two files and second is sort, right? If you have two such files and later point of time, you realize that those two files, if these two files were already sorted, will you change your approach? How? So there are two ways to do it. Using sort command, you have file 1 and file 2. You'll get the resulting output here. Or you could do or you could do cat file 1 and file 2 and then pass it to sort command, right? So if these were already sorted, what will you do? Okay, let's just take this example. Okay, so sort file 1, sort file 2 basically sorts the combined results. It combines and sorts. It does both. Okay, so I'm asking this question to all of those who use the sort command. If these two files were already sorted, this you came to know later, will you change your approach? Okay. So good part is the sort command itself comes with a flag called m, which basically merges the two resultant files. Okay. Now let me explain the same thing in a little more non-Unixy way. You had two queues of people who are already arranged by heights, who are already standing in increasing order of their heights. Okay. So my question to you is that if you have two such queues already and you have to make a single queue out of these two queues, will it make sense to just ask them to stand and then you sort them again? Okay, you just merge these two queues quickly, randomly, and then ask them to basically sort by themselves. Will that take more time? Or you say you stand in front of the both queues and call up the sorter guy first, and this way you will be able to merge these two queues into one. So which approach will be better? Second one, right? Right. That's exactly my non-technical way of answering that one, Madhav. Okay, that's good. So we are all convinced that if we already have sorted data and we inform pig that hey, you don't need to sort it again, it's already sorted. In those circumstances, it actually speeds up the process tremendously, because the process of merging two sorted data takes close to number of records. I mean, the time is proportional to number of records. If we try to sort it again, it will be number of records into logarithm of total number of records, right? So that's a huge difference. That's a huge difference. Therefore, if you come to know that hey, my data is already sorted, you are joining two tables. You joining two tables on a key on which this both data is already sorted. In those cases you just happily say using merge. Okay, and you will see a tremendous improvement. You will see a tremendous improvement in your output. Okay, so again, this is again pig's way of optimizing things, pig's way of giving you the control, because you understand your data and your logic more than what pig understands. Okay. I'm did I make it, did I confuse you, or was I able to explain it, Apur? Awesome. All right. Yes, go ahead, Naveed. Okay, okay. So Naveen, let me take it offline and we'll work it out, and let me also check it. All right, and we'll inform everybody if there is something missing in this example, which we talked in the beginning of the session. So, and also if you are just trying to copy the data from PDF to SQL, make sure that those quotes, specifically those single quotes or double quotes, they create a lot of trouble. Okay, so try look, have a look at closely. Like if I put here like single quote here, so automatically it get converted into these curly ones. Do you see that? If you put a single quote here, it becomes a curly one. So make sure when you are trying to run it from there, just have a look at the quotes. They cause a lot of trouble, and it automatically changes those double quotes to those curly ones. And you will be surprised to know that a single a double quote is represented five different ways. Five different ASCII values you have for a double quote. Okay. I mean, even single quote is like a problem. If you try to parse your data and you have got these double quotes, some from Microsoft Office and some from Macintosh, some from IBM, it'll be a horror. Okay, cool. So should we start now? Okay, let me start now. I've already asked that. Now, the next point after joining the sorted data is after joining the sorted data is joins, outer joins. Okay, let me make a point. All right. Now, so yesterday somebody was asking, what about left join or something, right? So Pig supports something called outer join. Okay, not inner join, only outer join. Okay. Now, and this outer keyword is to be applied on the first part. So join A by ID, then you say left outer, or you can simply say left. Okay, because that's the only kind of join it provides, right? This keyword cannot come at the end of it. We can't say B by ID and say left. No, this is the syntax. Okay, so instead of saying left outer, you can also say left. What does it mean? What does it mean is, in case in case a value corresponding to the left value is not found in the right section, still give the left value as is and put a blank on the right hand side. So, for example, one Sandeep has got a ID called 1 on the right hand side, right? When we are joining with ID, so it was able to find that ID on the right hand side. So it happily did one Sandeep and one Giri happily. But when we saw that for Ryan, there was no second name. There is no corresponding entity for ID equals to 2 in the right hand side. In such circumstances, it will basically put a blank over there. Okay. Earlier, when you don't put these keywords, when you don't put this keyword, say if you don't put, if you just simply say join A by ID, B by ID, what will be the output? Quickly, somebody. If you do a normal join A by ID and B by ID, what will be the output? Yes, only the first line would be there, right? So question number 6 and 7, if you notice that I think 7 or 8, question number 7 or 8, there, yeah. So what happens to 3 and Saha? We'll just come back to it quickly. So here, when we say left, meaning for an entity in the left, even if there is no corresponding entity in the right, let the left be there and right be empty or null. Alright. Now, for the right, if you want only the same thing for right, in those cases you use right outer or simply right. Okay. You can also say you can also say right outer. Okay. You can say right outer. Sound sensible to you? And note that the keyword comes in between. So in this case, for id equals to 3, there is no corresponding id on the left hand side, right? That is why, since we have put right, therefore all the ids of right would be there in the output, irrespective of whether it was able to find a particular id on the left hand side or not. Okay? Sounds okay to you or confusing to you? No, it doesn't have a syntax for inner join. All right. So you can simply say left join, right join, normal join, and the next one is full join. Left, right, full, and normal join. Okay. So in case of full, IDs of both sides would appear in the output, even if there is no corresponding ID on the other side. So therefore, you'll get 1, 2, 3, all three IDs in the output. For Ryan, there is nothing on the right hand side, therefore that part is null. And for Saha, there is no left hand portion, and that side is blank. Okay. So for those who were confused about SQL's left and right and full, they would get a clear idea here. Okay. And also note that this keyword comes only before this comma. Okay, it doesn't come here. That is a biggest cause of confusion in this. Now, so what will be the output here? Quickly, you have got A, B, and we are saying join A by ID, B by left outer. What will be the output? Good. It'll be an error. Awesome. Now, this one, A by ID outer and B by ID. Good. It'll be again error, right? Because it has to be the left outer, right outer, full outer. Okay. Or simply left outer full, or nothing at all. Sounds good. Sounds good to you. All right. All right. So now there's something called co-group. Co-group means that we want to join and then group. It's very often that we join on the same ID and then group by on the same ID. Okay? Let's say look at this syntax. What we are trying to do is for each animal we are listing down the owners as well as the pets. Okay? For each after joining these two, okay? After joining these two tables, what we are trying to do is we are trying to we are trying to group it by the animal name. For cat, the owner is Allison cat, and 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 the you know for and this cat there is Allison cat and Adam and cat, right? And for uh, so this is one set. This is one set here, and this is another, right? So okay, actually the data doesn't make much sense, so that I can give you a real use case. So it's quite often that we do so join A comma B, A by ID and B by ID, and let's say it results in C, and then we group C by ID again. Okay, it's quite often that on the same ID on which we joined here, we are we are doing a group by again, right? In those cases, right? In those cases, here when we join, right? When we are joining two tables using pig, internally it is going to do reduce. It is going to join these two tables, sort A as well as B by ID, then join them together. And again, when you do group by, it will again sort by that ID, right? So there are two sorting that is happening on the basis of ID, right? So in for to make it faster to optimize this process so that there is only one sorting happens, it basically tries to it basically tries to combine that into a single step so that sorting only happens once. So a quick question to you, those who are from computer science background: if you are forming binary search tree out of sorted data, is it faster or slower than non-sorted? Anybody? If you're forming binary search tree out of a sorted data, is it faster or slower than non-sorted? Are you sure? It's actually generally slower. It's generally slower if you see the heuristics. So if you take the default implementation of any binary search tree, one leg keeps on growing to a huge list, right? So the addition of each data becomes really slow. one of the leg of the binary search tree will keep on growing to all the records, and that's where the slowness starts. And at the end of it, the whole binary search tree formation will reach to any square in the worst case scenario if the data is sorted. That's the interesting part. Therefore, most of the algorithms try to avoid sorting a sorted data. Most of the algorithm actually perform bad in sorting the sorted data. Okay. So in the same spirit, here also, when group by C and the ID happens, it will get slower than the normal group by, because it's trying to sort the sorted data, right? Therefore, they came up with co-group. Co-group essentially combines these two into single step. All right. So if you do a simple join on these two, Adam cat and here whisker cat, okay, and then you do group by, then this is what you will get. Okay. Okay, it's opposite. It's first group by and then joining. Okay. You can see that output later. So basically it will have, this is basically each tuple. This is a tuple. Each tuple contains first field as the ID on which you sorted. Then it contains the bag of value. First bag, first bag from the first data set, this side, on where the cat was found, and then second bag from the right hand side where the cat was found. So this is what it looks like. If you look at the data, you will get the clear idea. Okay. So co-group is a cool thing when you want to group and join by the same data quickly. Okay. And next step, in case you don't like this format of data, you can simply do a for each and you can iterate over it. All right. So is co-group clear to all of you? All right. Now moving on. Those who are aware of union, they'll be able to correlate quickly. So the next syntax is union. When you have to join two files, not join as in the data from A and data from B, if you need to output that data, then uh, data as in first all the rows of file 1, then all the rows of file 2. If you want to do that, you will use something called union. Okay. Union essentially, union A comma B basically returns you all the rows of A followed by all the rows of B. If A has got 5 rows and B has got 6 rows, the total number of rows you will get is 11 in C after union. Alright? But the other syntax, which is called union on schema, is interesting. Okay? Union on schema is cool in the sense that uh, it tries to create that many columns. Actually, I think I should prepare an example of union or schema. Okay. So you say you have got A, you loaded A as some, yes, union returns duplicate data. Okay. Okay. Now, the other portion on schema is interesting in the sense that, say you have got dataset A, which has got column 1 and column 2. These are two columns, and we have value 1, value 2, and we have got B, which has got column 1 and column 3. Well, let's say B, and we say, well, B3. Okay. Now, when we do C equals union on schema of A and B, what we get is basically column 1, column 2, and column 3. Okay. Here you'll get well 1, well 2, and nothing over here. Basically, it'll be blank. And in the second one, you'll get value B1, and you'll get a blank here, and then you'll say, well, B3. All right. Does it make sense to you? So basically, it has tried to match the schema of A and B and tries to fit in the columns as in when required. So while doing a union of A and B on schema, so it basically tried to figure out what all columns are there in both of them and created the union of the columns. And after that, whatever columns were in both, they will get the values. Whatever columns are in either of them, the other value will be blank. Okay. So this is how it matches the schema. Because when we are defining load A here, right, we will say load A as X and Y and B as X and Z. Okay. And when we say union on A and B, this will essentially has, okay, it will have X, Y, and Z as columns. All right. Make sense to you? Vishal, did you get your answer of how did it match, or should I once again explain? So it does on variable name as well as type. So type is something which I also need to figure out. Let me figure that out. Can you show how union will look in this case? This case as in union on schema AB, this one. Okay, you are saying normal union. So if we have union A comma B, okay, so it will basically be column 1, column 2, and then well 1, well 2. Then essentially it will have well B1, well B2, well B3. Okay. And here it will basically, I mean, it wouldn't have a column header here. It'll look like this. I think I have a running example over here. So we have cat A, cat B. Okay, I don't have a running example. All right. Okay. In RDBMS it doesn't work, right? But here it's okay. Okay. All right. Let me also do it again because last time I had tried, as far as I remember, even if the columns in A and B were different, it basically ignored the differences in the name. Okay. All right. Now, right. So earlier in case of RDBMS, if you have to do a cross product, now imagine you have right. If you have a file one, sorry, table one, okay, containing adjectives. Let's call them adjectives. Okay. And let's say it has bad, good, medium, and then you had another table called nouns, and we say food, drink. Now we have to generate all combination of bad food, good food, medium food, bad drink, good drink, medium drink. What will you do if you have to generate this? You have got these two tables. Quick, anybody? You've got the in relational database, say MySQL, you've got these two nice tables, adjectives and nouns. And you need to generate all sorts of things like bad food, good food, and medium food, and bad drink, good drink, and so on. So if you have to do that, so Sanjay is saying Cartesian. Anything else you can do? The easiest way of generating all combinations of adjectives and nouns. Easiest way. I'm waiting. Anyone else? So let me ask you. Select star from adjectives, comma, nouns. What would it return without a where clause? Yes. Anybody else agrees with what Sanjay is saying? If you are in relational database and if you do this, wouldn't you get this? Right? Now, but problem is that in the syntax of pig, we always have to define ID while joining. And why so? Because under the hood, joining is nothing but a mapper and reducer. Mapper requires an ID, right? And therefore, the join always have an ID. Also, if you have select star from table 1 and table 1 comma table 2 where t1 dot value is greater than t2 dot value, okay, such kind of syntax is also not possible in pig. The way this is not possible, similarly this is not possible. All right. The only kind of join that can happen using pig are equality joins. Okay. So we can't have simply like this is invalid. We can't have something like join adjective and comma noun. That's invalid. Similarly, join adjective by something. No, that so now if you think about mapper reducer, you will get answer that why it's not possible. Okay. Therefore, if you have to do this kind of a Cartesian product, you have to use a they had to invent a new syntax called cross product. So you can say cross daily by divs and that do it in parallel. Okay. Also, when you look at the cross product, think through if you have to implement a cross product using your mapper reducer, how will you do it exactly? That is pretty interesting because that cross product idea itself is actually quite useful when you try to do matrix multiplication using using mapper and reducer. Okay. So when you do a cross product, you can use this. All right. Now, on the lines of what we had done earlier, on the lines of what we had done earlier, where we had Java code, Python code. Now, let's say that you have got a binary file. Python code, Java code was fine. We were able to import the jar. We were able to use Jython for loading Python code. Now, imagine that you have got a binary, a traditional binary. Okay. Now, this binary is some neither in Python nor in Java. It's there, right? Or it's in some language in Perl or in Shell or some other format it is, which is a legacy code. It contains some logic which is neither available in pig by default nor it's available in Java nor it's available in Python. Now what you do in this kind of scenario, right? Let's say you want to use sort command, sort command of Unix inside your pig script, or you want to use word count, or you want to use grep, or you want to use tr, right? Just like we did in our streaming job. If you have to do that kind of thing, then the stream command of pig is very handy, and you will realize the power of stream command when you will be churning the data, and some functions are not available in pig's library, and you can quickly use the shell commands. So basically, any command which takes input from standard input and gives output to the standard output, any command which qualifies as the Unix filter or qualifies at some program which can take input from the standard input and gives the output to the standard output, qualifies to become a streaming. library. In case it is not, then you make it such that takes input from the standard input by writing a wrapper over it. Okay. So the way you do it is you say stream my data set through this command. Okay, through this command, and note the backquotes. These are backquotes. All right. Why it is backquote? Their reasoning is that in case this involves single quote, double quotes, your command contains single quote, double quote, or something like that, then this won't interfere. That is why they have kept it as a backquote. Okay. The way we had SCD and then substitute single quote and then all of that, because that's a quite common phenomena. Therefore, they have kept backquote as the enclosing. And where is backquote? The key just before the one key, just above the tab. All right. So, so all it will do is it will take the whole row, this row by row, and pass it to this Perl command and read the output and move it to this one. Okay. Makes sense to you? And also note that this hidiv.pl should be giving you tab separated output. Okay. If it is not, then you have to use here using also, I think. Okay. So you stream your data through this program and note the backcodes. All right. And in some circumstances, as long as this program is available on all the machine, it will be able to run. In case it's not available, if it's not a command which is executed, say if it's grep, wc, or sort, sed, the Unix command, then it will be available on all machines. But in case this is something which is not installed on all data nodes, then it will be a problem. In those cases, you will have to ship it. You'll have to ship it. Okay. So you define the command and then ship the file. So there is a difference between shipping a file and a command. It might be like this. Okay. Say minus r x y z, right? So this is the whole command, while this is the file name of the file which needs to be shipped. Make sense to you? All right. And this is actually quite common. This is actually quite common whenever you are doing a migration, whenever you are going to convince your organization that, hey, why can't we move to Hadoop, and why can't we use pig instead of this one? Then you'll have to explain that in case of legacy code, your legacy code will remain as is. You don't have to do a lot of porting here and there. Okay. And you can basically keep on using the same functions. Okay. And interestingly, these kind of things are very difficult to do using any of the. Right. So now so Naveen has got a question. Ship command will ship the source file only when the target doesn't have it, or will it forcefully send it to all machines irrespective of whether they have it or not? It will forcefully ship it, and the context will remain yours. Okay. How does it run? Just like your shell command runs a command, it will run in the same way. It will do a system call, run that binary, and then make it happen. Okay. Native binary, you are talking about a binary that comes with Unix, or it comes with your own library. So if you have got a C++ library, and that is only installed on one machine, you have two options. Either you try to install this library all across your data nodes, or if you can ship it separately. Ship means copy this file somewhere on the data node and then execute that one. Okay, put that in path and execute it. All right. So if your program requires an installation of an exe, or installation of a dll, or installation of some so files, so is the compilation units of C++, then if you do that, then it will not be possible using the normal ship command. Ship is basically copying this file everywhere, making it available to the shell. It's like saying, uh, uh, copy this file onto a /tmp somewhere, and then saying export path equals dollar path colon this /tmp this folder name. All right. And whenever you are saying hidiv.pl, that gets done there. All right. Now that was the pig streaming. All right. Now, since pig effectively is going to get used in sort of reporting everywhere, it is actually used in reporting. Just like you have those reporting engine generators, you have a lot of SQL and that data gets generated and all of that. Now, pig script, pig script basically has the same phenomena, okay, where your script might be being run every day with different arguments, and arguments can be coming from the command line or coming from a different file containing all the arguments default value, or elsewhere from the environment variable, for example. So so you can use this way. So you have got one script file, and you can use dollar to refer to a variable. Okay. So, and the way you define that this variable is from the command line argument, just like this. Okay. So when we are executing pig my daily.pig, we can pass few variables from the command line. If you have multiple ones, you can put multiple minus p on the command line, and those variables will be made available inside your daily.pig script. Okay. And you can refer to those variables using dollar. And similarly, in case you have got hundreds of such parameters, as I was talking, if you got more than two or more hundred, so instead of keep piling them up on the command line argument, you can put them into another file and then use minus param file as the argument to access it. Okay. So now when you are scheduling it, all you need to do is schedule pig, or schedule this, and where date is being generated every day, today's date, and then run it. Okay. So that makes it possible to run the parameter substitution and makes it a suitable tool for the generation of the data every day. Okay. Now there is another interesting command there is another more interesting than the previous one is splits. Okay. Now you have got a huge data. Some of this data need to pass through one leg, I mean pass through one set of operation. Some of this data has to pass to different set of operations. Now you want to convert this huge data set into two separate data sets, or maybe three, or maybe 10, right? Now what you do is you do a sort of a split. You say split your data set, say you loaded this, and say split my data set into April 03, 02, 01. Okay. 03 says if timestamp is lesser than this, a- and so effectively after these operations you will have three data sets. Okay. 01, 02, 03. Okay. April 01, 02, 03. Okay. Now, so this way we have splitted one single data set into multiple. And this splitting is not like, you have sliced it such that these are three different sets, three mutually exclusive different data sets. No. A record can exist in more than one location. If you see the data, this one says April 03 says all the data up to April 03, while April 02 says all the data from April 3rd of April till from 1st of April till 3rd of April, right? So April 2 and April 3 has common data. Okay. Similarly, here April 1 contains the data after 31st March till 2nd of April. So April 03 and April 01 have data, and similarly they have common data. And in this due course, the data which is beyond 4th April is being dropped. Okay, it is completely being dropped. Some data is being replicated and some data is being dropped. So split is little misnomer. Okay, split, this is more like fork, more like um data generator, where based on one data we are generating multiple data. Okay, so a single record could go to multiple legs, and a record call could also be dropped out. Okay, do you guys are you guys able to relate when to use such kind of operations? Point one is a single record could go to multiple record. If you see the data, the data with timestamp of 1st April is actually going into all three: April 1, April 2, April 3. Sorry, the data which is of April 1 is actually going to April 1 and April 3, right? So can you guys visualize that when do we use this kind of splitting? Now imagine this, that there were three different kind of operations you need to do on this data. So you have got huge Apache logs. You got huge Apache logs, and you know that before the 1st of April, the way we were storing our Apache log was different, and hence it needs a different kind of churning. And once we have finished churning, we have to merge these records back. Merging is simple by doing a join, right? or by doing a union, howsoever you wish to do, right? So basically, when you have data and some subset of the data need to be operated in a different manner, and other need to be different done in another manner, then you can have this. Okay, this makes it possible to read a file only once to generate multiple data set. Otherwise, what could you have been doing? First load, what would have been alternative? Load weblogs into weblog 1, weblogs into weblog 2, load, or just load weblogs into weblogs, and then generate three different data sets by doing filter command on top of wlogs, right? Three filter commands, remember, you would do three filter commands, and each filter command will result in multiple mappers. So let me tell you how. What do I mean? So ideally, if we did not have, so let's say we did not have a split command, we had this. Okay, now what we will do is we will have April 3, we'll say April 3 equals filter wlogs, filter wlogs on filter by timestamp less than this, right? And so on, right? Something in this, something in this. Okay, now we got three data set here. Now if you see, there is not much of a difference between this and this, right? Or is it? In this we are saying, no, you don't need filter. For filter command, you don't need a for each. We could actually do it using for each also. Okay, so what's the difference between this and this? You might ask, right? This one will be generating multiple mappers. This will be one mapper, this will be another, this will be another. Here, there is a single mapper which is doing the job. It's a single mapper. That's the difference. So this is an optimization step. All right. So uh, again, the step which was there in the previous one, basically internally must have generated a if condition or switch case inside the mapper where it generated this output and gave it to the user. Okay, and sometimes it might generate multiple map jobs depending on what we are trying to do. Okay, it does a lot of optimization. Pig does a lot of optimization to your inputs in order to make it really faster. Okay, all right. So for detailed documentation on pig, the best reference actually I found on pig is their online manual. that is probably the best de facto place, and probably that is what you will require now. Okay. Whenever you are starting to work, you might have to look up the definition of each function. That is something which I have not covered, the definition of each function. Other than counts, other than average, you can actually look up and see there are a lot of functions in the library. If you go to this place. Also, those who are inclined into the development aspects using Pig, they would like to go through the custom load functions. Okay, custom load functions, as in the way we had pig pig uh, loader. Similarly, there is there you can create your own kind of a loader. Okay, if your data input file is such that it cannot be handled by the standard ones, then you might have to write your own program for loading. Okay, or maybe your data is in a data source which is not usual file system. In those cases, you might have to create your custom loader. Okay, so this is pretty much about Pig. And today, as part of today's exercise itself, the exercises which were given yesterday should be sufficient enough. Okay, so please finish the assignment. The assignment is fairly simple, and it should not take more than an hour or 2 hours to finish the exercises of Pig. And if you have any doubts, ping me. And Naveen, feel free to share the logs with me. I'll also have a look at what is the problem you are facing with respect to Pig. So, did you guys sleep off while I was talking? Because it has been more of a monologue. Okay. Okay, so everybody's awake. Good, good. Makes me feel good. Okay, I just added myself to the group. And cool, cool. It makes me feel actually good that I'm not an admin of this group. All right, so you can join that group. And also, we are in process of launching forums, and so that all the questions you guys are asking can be answered over there. So if you say no big data slash forum, you can see the technical forum. It's not as beautiful as Stack Overflow is because we couldn't find a better one for the website. So here we will be very active in basically any question you will be asking. I'll be copying that onto the forum and will be answering that. Okay. Okay, we will try our best. All you guys also try to answer people's question here, and we will be also posting the job openings and other stuff into the forum. Okay, and that pretty much completes our big discussions. Okay, so now I'll be starting. No, we are not finishing this. We are starting Hive now. Okay. So we'll just say hello to Hive and then move on for our next session. Yeah, yeah. So, all right. So, All right. So there are some circumstances where there are a lot of people who know about SQL. There's a lot of scripts already written in SQL for relational databases and SQL. And it's actually difficult to move people from a technology suddenly and say, hey, now from tomorrow onwards you are going to work on Pig or Pig Latin, right? Therefore, it is very, very important to to basically support standard SQL on top of MapReduce. Okay. So with that in mind, because there are lots of people who are pretty good experts in SQL, and probably every engineer, every software engineer knows about SQL. There are lots of code already people have written in reports in backends, and there's a lot of infrastructure, SQL infrastructure already available. So that is the reason why why thing like Hive exist. Hive basically the way Pig converted Pig Latin into the way Pig converted Pig Latin into MapReduce without you having to write any code. On the similar line, Hive essentially does the same for you. Okay, it takes the SQL and generates the code. Sounds okay to you? While we had Pig Latin is fantastic language. It's just that not many people are educated enough with respect to Pig Latin. In case of MapReduce, even person like myself who think that he's good at Java and he's good at MapReduce hesitates and even find it really really repetitive. And sometimes I myself found it difficult to code. Uh, I mean, it took me more than half an hour. It took me around 45 minutes to code the matrix multiplication. So, so, so MapReduce is little difficult for lots of people. Okay, even for developers. Therefore, therefore, the people need to learn Hive. Right, right. That's right. Okay. So basically, you can query your HBase, you can query your HDFS, CSV file, tab separate file using Hive also. And the way you communicate with Hive is using a standard SQL. And the on top of that, Hive provides you something more beautiful. Hive provides you that your one table one, could exist in MySQL, and table two could exist as CSV file on on the file system, on in HDFS, and file 3, I mean table 3 could exist as a S on S3 bucket. S3 bucket is Amazon S3 bucket. Okay, and you can join these three tables to get the desired output. Okay, similar thing could be done in Piglatin also, but SQL makes it easier for lots of people to learn and start. The value proposition of Hive is it's mostly suited for data warehousing applications where you are analyzing static data, relatively static data, where a fast response is not required, because in any batch process, in any Hadoop MapReduce batch process, there is a boot up time associated. It takes some time to start the process. Therefore, any SQL you run on Hive would look very, very slow to you. If you're coming from RDMS background where things run in milliseconds, here it might go to 10 seconds, right? So, so this is the value proposition provided by Hive. It provides a SQL dialect which is very close to Oracle's SQL. It's called HiveQL. It keeps the metadata since Hive is going to analyze the data from structured as well as unstructured places. If the data is coming from CSV, you need to maintain a metadata defining the data. Okay. Therefore, therefore it stores the metadata in MySQL. Okay. Although now it has moved to Derby, but mostly up to point 0.7 it was MySQL. All right. A quick, a quick limitations before we move forward. Before you start thinking that it is the solution to the all big data problems, it does not provide you record level edits. There is no such thing called update my table where this is that. That's not possible right now. Or insert into my table is also not possible. Record wise is not possible. But you can say select from a table where blah is blah and store this into a new table. So the whole set can be stored once. So is Hive querying slower as compared to Pig? Okay, that's a very interesting question. And let me just take a note. I believe that Pig would be faster because Pig can be fine tuned. Okay. Pig can be fine tuned when you realize that your data is already sorted, you have skewed, or you can use replicated behavior, and you can also do parallel. So Pig can be made faster, while over Hive you don't have much of a control. All right. Also, it is not suitable for OLTP, as I told that Hadoop is batch oriented. So each job takes its sweet time to finish, and therefore most of the MapReduce processing is not suitable for online transaction processing. Okay, online transaction processing or stream handling. So Hive is great when you have relatively large data set to be analyzed. Okay, and to be analyzed and maintained. So hope limitations are clear to you guys. Now this is a common architecture of Hive where, hey guys, do you are you able to tolerate it, or should we do it in the next session? To me, it looks like you guys. I mean, should I continue or should I next session? Okay, looks like it's too much for you. All right, all right. Let's do it again next session. All right, great. So please finish the assignment, and in case you're stuck anywhere, just feel free to drop me an email. All right, and also start. If you have a question or something you want to ask, you can ask in the forum also, because I'll be anyway putting your all questions into these forums. Okay, and this forum is going to be public in the sense that so don't share something which is private. Okay, this forum is in public. Okay, so it is anybody can access whether they are logged in into LMS or not. So be cautious when you are writing a question or something. Okay. because whenever I will be taking your questions and putting it onto these forums, I'll be removing any private data. All right, these forums are going to be public. All right, even though your question may not be pertaining to any to only big data and Hadoop. If you have a question about JavaScript, Python, or Unix, or maybe something which you is not part of this course, still you can ask, and I will make sure that I answer it appropriately. All right. So I'll be working on maintaining the sanctity of this forum so that everybody gets benefited. And okay, so all right. So in the meantime, be feel free to ask your questions in this. All right, guys. Right now, this forum is not publicly visible. Okay, okay, okay. So right, right. So feel free to ask your problems on this forum. I will immediately look into it and then start working on it. Okay. And Naveen, you can also ask this question on this forum. I'll answer there. All right. Cool. Cool. So this will act as a support forum as well as it will act as a general technology part. But make sure in case there is some confidential data, mask it or just send an email to me. Not me, Hadoop at knowbigdata.com. Okay. So the forum, I think, and okay, have a good week ahead and good night. All right. Awesome. Have a great day.